Hello, let us look at some differential equations here. Um, we're going to be focusing on differential equations here. Now, in the first one, dy over dx is equal to given in this expression. That we are looking for particular solution that passes through 0, 2. How are we going to approach this? You see, the first step which we have to do is separate the variables, hence the name separable differential equation. Then we get y dy, and the other side is equal to negative x over e to the x squared dx. Now we have to integrate this one, but before we do that, why don't I just express this one in this manner: negative x and then e to the negative x squared dx. That might be a bit easier for us to look at. Then when you integrate this, you can see that our left side would have been y squared over 2 equals, on the right side, in fact what we have to do is, why don't we use u, substitution, u as negative x squared. Then we get du becomes negative 2x dx. Notice that we have negative x right over here. Only thing that we don't have is 2. So therefore, this can be still equal to integration of e to the u du. Since we don't have 2, I'm going to just divide by 1/2 here. Now, then once you integrate this, we will get 1/2 e to the u. But what was u? U was equal to negative x squared plus c. Don't forget c over there. But this equation has to satisfy 0, 2. Then when I plug in 0 for x, 2 should be plugged in for y. So we get 2 squared over 2, which is equal to 1/2, and then e to the 0 is simply 1, so plus c. Then we can easily see that c must be equal to 3 over 2. Then what we can do is we can plug in 3 over 2 in place of c, and then we'll figure out the rest. And so far we have y squared over 2 must be equal to 1/2 e to the negative x squared plus 3 over 2. Once you multiply all sides by 2, then we get y squared must be equal to e to the negative x squared plus 3. Then y must be equal to square root of, technically it can be plus or minus, e to the negative x squared plus 3. But remember, we have to get 2 positive values, so our answer should be here, square root of e to the negative x squared plus 3 would have been our final answer. And which one will that be? It seems like choice D is the answer here. Alright, let us look at number 2 here. Once again, if I were to rewrite down this expression, it will be equal to dy over dx equal to negative y, given that y is function of x. And this is the initial condition which we have to satisfy. Then I can rewrite this one as dy over y, which is equal to negative dx. When you integrate both sides, then we get ln of y is equal to negative x plus c. And then I should be able to plug in 1 for both. Then we end up getting ln of 1, which is equal to negative 1 plus c. ln of 1 is equal to 0. So we realize that c also must be equal to 1. Then we end up getting ln of y must be equal to negative x plus 1. That makes y, when you raise both of them as an exponent of e, then we get e to the negative x plus 1. So anything that's equivalent to that would have been our answer, which is choice C. Alright, let's move on to the next question. Here we have, in fact we have double derivative corresponds to the first derivative, and then so forth and so on. Then what do we end up getting? Let's try to calculate this one first. Let us assume that second derivative like this is equal to the first derivative. Now, if you calculate it in this manner, it might be a little bit more confusing. So what I'm going to do is this. I'm going to assume that second derivative is in fact derivative of let us say g, which is the second derivative of f. So I'm going to try to use this one first. Then, first, what we like to do is this: dy or dg x would have been equal to 2 times g. Now, then we're going to do separable differential equation just like before, so we get dg over 2, dg over g is equal to 2 dx. Once you integrate this one, we get ln of g must be equal to 2x plus c. But notice that when x equals 0, y prime is equal to, or in this case g will be equal to e, so I'm going to plug in ln of e must be equal to 0 plus c. Then we can see that c must be equal to 1. So here we get ln of g is equal to 2x plus 1. That means what is g equal to? G is equal to e to the 2x plus 1. But notice g is the not y but y prime, as you can see here. Then we need to integrate it one more time. Then what's going to be happening? Since g then is equal to f prime, combining these, f must be equal to integration of g, which is equal to e to the 2x plus 1 dx. What do we end up getting? That's right, this becomes, by u substitution, we get e to the 2x plus 1 over 2 plus c. Then you can see that once again, that when you plug in 0 for x, the y value has to be equal to e. Then I'm going to apply that here. E is equal to, when you plug in 0, we get e over 2 plus c. Then you can see that c is equal to e over 2 once again. So therefore, our y value, which is function of f of x, is equal to e to the 2x plus 1 over 2 plus e over 2. Now, then, in this case, we're not looking for as they are, but we are looking for when x equals 1. So if you have to plug in 1, our value will be equal to e to the 3 over 2 plus e over 2. So obviously we can factor out e over 2, and we get e squared plus 1. So that looks like choice A is our answer. Alright, let us move on to the next question, number 4. So now we are looking at dy over dt in this manner. What is the value of t and y? So we need to figure out what y is equal to first. Then we're going to do the same thing as before. So first, separating the variable dy over y, which is equal to negative 2 dt. Once you integrate both sides, we get ln of y, which is equal to negative 2t plus 1, and plus c rather. Now I'm going to plug in 0 and 1 in place of t and y. Then ln of 1 is equal to 0 plus c. then you will realize that c must be equal to 0 because ln of 1 is equal to 0. Then we can see that y is equal to e to the negative 2t is our equation. Now, given that y is equal to 1/2, then how do you figure out the value of t? Then 1/2 equals e to d. So then to get rid of e, we're going to take the ln on both sides, which actually goes back to the previous question anyway. Then ln of 1/2 is equal to negative 2t. Then we can see that t must be equal to ln of 1/2 over negative 2. Now, let's try to check out our choices. None of them has 1/2 as 1/2 of ln, ln of 1/2 in fact. So therefore, if I have to rewrite this one, then we get ln of 1/2 is negative ln of 2, because this one is equal to 2 to the negative 1 power over negative 2. So negative negative cancels out. Then what we end up getting is t is equal to ln of 2 over 2. So that's basically what we end up getting. Choice C becomes our answer. Alright, let's look at number 5. At each point x comma y, the slope of the curve is this. Then once again, if I have to rewrite that, then it becomes dy over dx is equal to 3x squared y. Now, then if you were to separate the variables, then we get dy over y must be equal to 3x squared dx. Let's integrate both sides. Then we get ln of y must be equal to x cubed plus c. Now, the point which we have to plug in is 0, 8. So when I plug in 0 and 8 here, ln of 8 is equal to 0 plus c. Then you can see that c must be equal to ln of 8. Now, then we know that our equation is ln of y must be equal to x cubed plus ln of 8. When you raise both sides by e as an exponent of e, then we get y equals e to the third power, not third, x to the third power x to the third power plus ln of 8. Now, when you have addition, then they can come out as a product on the base of e. So we get e to the ln of 8. But e to the ln of 8 is simply equal to 8. So we get 8 times e to the x cubed. So that's basically what we end up getting, which is choice A. That becomes our answer. Alright, so I'm just going to stop here as a first part, and we'll continue very soon. I'll see you later. Bye-bye.